Good morning, Your Holiness. Today it's my privilege and task to be the moderator, so you don't have to listen to me present. We have two wonderful presenters today that will be speaking to you about changes in the brain and the neurosciences. Yesterday we spoke much more about the intricacies of the natural world, the world of physics, and especially contrasting the world of classical physics with that of modern physics. And we learned something about the ways in which the interconnectedness, the holism of nature is now more and more a part of our worldview. Even our technologies now can make use of this interconnected, holistic aspect of the subtle dimensions of the physical world. We also spoke about how Madhyamaka philosophy chooses a middle path between a kind of naive realism and a mind-only school of projection. We saw how that also seemed to relate to the foundations of quantum mechanics and relativity theory, and how these scientific theories seemed in harmony with that philosophical position. All of this was done again at the hand of the natural world, the world of reality outside of us. And we can think of that exploration, that investigation of the natural world either by the methods of Buddhist philosophical thought or the world of physics as part of the exploration, coming to clarity and wisdom concerning the natural world itself. And I know Your Holiness also has such a relationship to the environment, that this study of nature is also something which is not merely intellectual, but allows us to establish a heart connection also to this world of nature, to its beauty, its grandeur, and that it's important for us to care for that world as well. I think of this as one path, a path that takes us from ourselves and into the world of nature, its beauties, its mysteries, its subtlety. But there's another path, which is the path that takes us to the mind, a different threshold, a different crossing into the mysteries of consciousness. And we have today two remarkable scientists, both of whom are known to you. Richard Davidson, of course, at the University of Wisconsin, who is the director of the Weissman Laboratory for Brain Imaging and Behavior, and also for the Center for Investigating Healthy Minds at the University of Wisconsin. He's known to you as a neuroscientist and cognitive affective neuroscientist of the highest rank and order, and of course one of the early members of the Mind and Life family, and has been with us for a long, long time. We also have Tanya Singer, who sits to my right, who you also know, who helped to co-found or organize the Altruism and Compassion in Economic Systems conference in 2010 in Zurich, but is also a neuroscientist of an extraordinary caliber in Germany, now directing a Max Planck Institute for Human Cognitive and Brain Sciences. She brings an enormous capacity and expertise here with her from this, and that's with great joy and gratitude that we are welcoming her into this circle once again to present to you from her standpoint. And so with these two capable individuals, we now begin our path into the mind through the lens of science. So Richie, I'll turn it over to you.
Thank you so much, Arthur, and thank you so much, Your Holiness, and thank you to all at the Drepung Monastery for making this a very, very special and momentous occasion for us. For those who are visiting, it's been really something very different than any other Mind and Life meeting, and I think we all feel it in our hearts and understand at least a little bit, I think, how important this meeting is for Your Holiness and for the monastic community. And I think, speaking on behalf of all of us, I think we all feel a real gratitude to play a small part in the curriculum change that this event is really celebrating. Today, Your Holiness, I will begin to talk about neuroscience and also contemplative practice. On the very first day of the meeting, I said a few words and talked a little bit about the complexity of the brain and how it's probably the most complex piece of matter in the universe. After sitting through yesterday, I'm deeply humbled by my physics colleagues, and I think that neuroscience now is a much easier task than after knowing what my physics colleagues have to struggle with. So we'll see at the end of today what the collective judgment is.
More complicated because the brain specialist in any way is dealing with mysterious such as consciousness. You cannot measure man. More mysterious, more difficult. Your task is more complicated.
So, Your Holiness, today I will first talk about two major systems in the mind, if you will, or two major constructs. One is emotion, and the other is attention. And I talk about these because from the perspective of Western science, there seems to be consensus that contemplative practice affects these processes. That is, it affects our emotions, it affects our afflictive emotions, it affects our positive emotions, and it also affects our attention. And so, from a Western scientific perspective, it makes sense to us to begin this project by focusing on these constructs which we think are relevant to the impact of mind training. And so I'll begin by asking, what are the key neural circuits that underlie emotion and attention? And then we will consider the idea that these circuits are plastic, meaning that they can be transformed by experience, and therefore they seem to be relevant for the opportunity to be transformed by contemplative practice. And then finally, I'll talk about the impact of different kinds of contemplative training on both emotion and attention, and I'll give one or two examples. And so that's the plan for this talk. I want to begin with an important figure in psychology and neuroscience from the West that has already been mentioned at this meeting, and this is William James. And in addition to his insights about attention, which we've heard a little bit about and to which we will return later this morning, William James also had some brilliant ideas about the nature of emotion. And I'd like to share William James's understanding concerning the nature of emotion, and that is depicted in this diagram to the right. And I'll walk through this diagram. If you look at the right-hand side of the diagram, it says sensory receptor. Those are the sense organs, the eyes, the ears. And William James's notion is that sensory information comes into the brain through the sense organs, through the eyes, through the ears, and so forth. And it goes up to the cortex through some relays, which we'll talk a little bit about later, but eventually it reaches the cortex, the highest level of the brain. And then from the cortex, if you look at the arrow that is denoted number 2, there is a line going from the cortex down to the viscera, which are our visceral organs like the heart, the lungs, and so forth. And so there are projections, there are connections. This is William James' view, but this part of it is clearly confirmed by modern science. We know that there are pathways from the cortex that go to the heart, that go to the lung, that go to the different visceral organs. That is known, and that's not controversial. So,
Solon is asking, are you suggesting that these visceral organs play a role in perceptual processes?
they play a role. They play a role in emotional processes. So the idea is that the brain is perceiving the senses, and then once the senses are processed, the information goes from the cortex down to the visceral organs and also to the skeletal muscles, to the muscles in our face, the muscles in our body. And then just to continue, the arrows that are denoted number 3 project back up to the brain from the visceral organs, from the heart and the lung, as well as from the skeletal muscles. They project back up to the brain. So for William James, what he argues about emotion is that when, for example, if we see a tiger in front of us, the sensory information goes up to the cortex. The cortex sends signals down to the heart, down to the lungs, down to the muscles, and we experience our heart beating more quickly, we flee, and then he says we experience fear only after those changes occur in our body. And so for William James, the changes first occur in the body, and then the signals from the body go back up to the brain and inform the brain about the state of the body. And then once the brain detects that the body is agitated, then the experience of fear arises. So in a very famous passage in William James's book, The Principles of Psychology, he says, we see the bear, we run, and then we are afraid. So this is a view which has had a very deep influence.
No, that Jignana de the Longunjura, Longunjura, Longunjura in Dugal that.
So one occasion, some scientists used to told, fear develop, then the muscle goes leg, the blood
goes
more.
into them.
So obviously, anger comes, then blood circulation go hand, ready to boxing. So that means, you see, the physical sort of change, this blood sort of, also the rushing. That's naturally related to the heart and some other sort of body element. But trigger of that is here, feeling, fear.
The fear.
So I thought, fear come first, then physical reaction come later. So you just opposite.
That's right. So this is William James's view. So which is right? So how can we test this scientifically? So I will provide one example of how this can be very rigorously tested to provide an actual empirical answer to that question, which comes first? Is there a way to tell? So in the West, Your Holiness, it's a little bit strange, but there are people who go to their doctors to receive injections in their face to make their face look younger. They receive injections of a molecule that is called Botox, in short. And what Botox does is it paralyzes the muscle for some period of time, and it eliminates the wrinkles. And some people voluntarily go to their physician and get an injection of Botox to make themselves look younger. So we actually did an experiment.
So someone said that, so was saying that if you go too extreme one day, you might not even be able to close your eyes.
That's true.
blink soll du.
Yeah, to blink.
It's true. It's true. So we did an experiment. This is published in the scientific literature, where we decided we can take advantage if people are voluntarily doing this anyway.
That's right.
What we did is we tested people before and then after they received a Botox injection to the muscle, one of the key muscles in making certain kinds of facial expressions, the corrugator muscle, which contracts during sadness, for example, very important. And we then were able to test the same person before and then after we eliminate the skeletal muscle contribution that goes back up to the brain. And so this is an important way to test William James's theory, because we're not changing the brain directly. All that's changing is the signals that would arise from the muscles that then go back to the brain. So we can, at least for the skeletal muscles in some key regions, we can eliminate that feedback that goes back to the brain, and we can ask the question, does that change a person's emotional response? And the answer is, it does. It has some effect. And so that experiment, as well as several other experiments like that, suggest that at least to some extent, William James was correct. Where he was not correct is in thinking that all of it is due to the feedback. So it goes in both directions.
Now safe though. 찾아내보세요. 그렇게 인 거죠.
말이 찬이가 레베난 마 베스로도 마다다 미네야 다다 촌니가게 돈에 연구요레스 가브리 멤버체. 단데 윌리엄 제임스 송베나 담봉엘레 왕부 티체 안 왕부 레벨 레벨 마다 당샤 마다 어디 나 지나게
제일에서
제일에서 단디 크란스는 다 촌니가 투서
So another important figure in the history of research on emotion is this scientist named James Pepys, it's pronounced, Pepys. And he was the first to actually describe a circuit in the brain that is important for emotion. Not just one location, but the interaction among a group of structures in the brain. He was the first to describe that. And his description is in this figure, and it includes a number of different parts of the brain, such as the hippocampus, which I'll talk a little bit more about in a few minutes, another part of the brain called the cingulate. But all of the key parts of his circuit are enclosed in the dotted square. And notice that the neocortex, the highest part of the brain, is outside of that area. It's not part of the circuit that Pepys described was important for emotion. Now, this is very important in the history of neuroscientific research on emotion, because it was suggesting that emotion is processed in parts of the brain that do not involve the cortex. And this was the classical view of emotion for many, many years. And then one of the things that changed that view, one of the most important things, were studies that were conducted primarily from individuals from World War II who suffered damage to their brain in the war. And one of the things that was found is that patients who had damage to the frontal lobe of the brain exhibited abnormalities in their emotion. That is, they showed certain kinds of emotional disturbances. And those were some of the first insights that suggested to scientists that in addition to the parts of the brain that Papes and others have described that lie below the cortex, that the cortex itself, at least certain parts of the cortex, particularly the frontal cortex, may play some role in emotion. And so what might that role be? And that has been the focus of a lot of basic research that we have conducted in our lab, but also many other scientists. And the modern understanding suggests that the capacity to regulate our emotions is importantly associated with the frontal cortex. And one of the things that may be different in humans than it is in any other species is our capacity to regulate our emotions. No other species can voluntarily regulate their emotions in the same way that humans can regulate their emotions. And we think that that probably has a lot to do with the growth of the prefrontal cortex over the course of evolution.
Emotionally, His Holiness is wondering, are you suggesting that other animals are not capable to the degree to which we can exercise regulation?
But otherwise, we can notice that we notice some dogs, some birds. Although they are, I think, physical level, they want something. But mental level, they fear this sort of little suspicion.
So His Holiness is suggesting there seems to be some ability to regulate. They don't, just keep a check on their instinct.
In that case, with the bird, if they want something, but they have some suspicion or wariness, the suspicion is likely caused by something in their environment that's right there, that's present immediately in their environment. So it may be some...
that is true. That's true.
Whereas in humans...
But still, you see, there's sort of differences. Yeah. The physical level, biological factor, is you want something, you're hungry, want to eat. But another sort of level, mind, warning, be careful. In an animal also, you have that capacity, isn't it? So it's two levels to what?
So to a degree, they do have an ability to sort of put a check, control over their instinct.
To a degree, although that control is in the immediate environment. It's not something that they can call upon purely mentally. It has to be present in their immediate environment.
But could do daily in Gungdua,
yeah, but that His Holiness is saying he's not sure if that is necessarily true.
Also, a certain memory, not like human memory, 10, 20 years sort of memory, no. But I think at least a few months, if a bird or cat or some other mammal, so once they had some kind of difficult experience, then at least memory remain another, I think, a few weeks, a few months.
Yes, yes. It is a matter of...
Yes.
It is a matter of degree. It's not absolute. It's a
Yeah,
matter
the
of...
degree is limited.
It's a matter of
That's no
degree.
question, yes.
Yeah. And there's a very famous set of experiments that's been done in children where if you have a treat that a child wants, something, a delicious candy that they really like, and you put it right in front of them and you tell them they can take that candy right now, but if they wait 5 minutes until the experimenter comes back, they can have 3 candies.
Yes, yes.
And this is a very famous experiment. And some children have the capacity to exert self-discipline.
And age. Can you say the age of those children?
Pardon?
The age.
The age of these children is about age 5 or 6 years of age. And one of the things that's striking about this is the variation across children in their capacity to do this. Some children are able to exert discipline very, very well, and other kids will look at the treat and then just grab it. And it turns out that if nothing else major changes in their environment, when they grow up and they're age 30 years of age, the children who were better at exerting discipline when they were young end up with much better outcomes. They have better ability to regulate their behavior in all kinds of ways. They are financially more successful. They're less likely to get into trouble with drugs. They have all kinds of more positive outcomes as adults. And so this actually is a very important insight because it suggests to us that if we can teach children to exert self-discipline in this way, in a more effective way, then we can actually benefit outcomes later on in life. And this is something that requires the prefrontal cortex. This is a skill which is clearly mediated by the prefrontal cortex.
第二的要去投入，아도 부디 지 까먹고 지숨러그레스. 어디다 캐치톤. 지직래 지숨디 캐치하여 있잖아요. 까먹고봐. 다 고린 저로 차거다. 다디 떠난 거 더네. 셔셔와. 다 저 까먹고 그레스. 직난 건 까먹고 그레스. 러니부터 기억하도.
So His Holiness is wondering whether the experiment has done. I mean, here it's an incentive. So the children has been exposed to this candy, and has been promised 3 candies if he can wait for 5 minutes. So there is an incentive. So the children knows that he's going to get more. So there is a sort of a anticipation and a joy.
So actually, a certain kind of motivation of positive thinking. So I wait 5 minutes, I gain better sort of
results.
Result.
There is an anticipation, something that the child likes. But how about if we do the other way around, where the child is given a candy in front of them, and you just give them a warning that you should not eat it. You should wait for 5 minutes, and maybe even suggest some punitive consequences.
If not listen, some kind of threat. So out of fear, wait 5 minutes. Another one, wait 5 minutes out of volunteer, seeing some positive, seeing some benefit.
The benefits, no?
Yeah, so well...
So you mentioned that those is a child more disciplined, whole life becoming more successful.
Yes.
So some kind of discipline out of fear.
Can it work
not that kind of positive effect.
Yeah, that's a very good point, Your Holiness, and those experiments have not been systematically done to compare a motivation out of fear versus one out of a joyful anticipation. But there are other experiments that suggest that positive motivation will lead to more enduring and sustaining of behavior change than punishment. So I think that that intuition certainly is borne out by some other scientific evidence. So this is just another diagram of what scientists, some scientists have talked about as the limbic system, which is the system important for emotion which interacts with the prefrontal cortex. And one of the areas in the limbic system is this area here, which we've talked about before, called the amygdala, which I'll say more about in a few moments. But the idea that I want to emphasize here is that emotion, just like any other type of complex behavior, is not localized to any single place in the brain. It is distributed throughout a circuit where there are different structures that interact, and the activity of those structures interacting, according to modern neuroscientific view, is what is necessary for the emotion to arise. So it's not that it's located in any one area. There is no single place in the brain that we can say that's where emotion resides.
The other level is our because we begin that diagram secretary that moves your the as a me localization level and the children young group what 찾아서 찾아라.
So not specifically in relation.
내도 예배 그도네 나 그제즈네 또 찾아래.
So not specifically in relation to this particular diagram, His Holiness is asking a general question about the brain mapping and the anatomy of the brain.
Oh, this kind of map.
Yeah.
So what age? I'm wondering this kind of sort of complete sort of form of brain
Emerges.
After
Conception.
Conception.
In the fetal developmental stages.
6 months, 8 months.
Within the fetal development.
Yes.
It's in the last trimester, so in the final 3 months of gestation, major structures of the brain are formed. But and so all of these structures are present at birth, but they undergo postnatal development. So there's a lot of change physically which occurs in these structures up until at least age 25 years.
That's right. That's right.
So there's
once Livingston after birth, mother's physical touch is the one major factor for enlarging brain. So which side of brain?
Well, again, the warmth of a mother probably affects many different areas of the brain, not just one, and it clearly influences the development of areas in the limbic system as well as areas in the cortex that play a very important role in emotion and emotion regulation. We know the evidence for that is extremely compelling. We know, for example, Your Holiness, that the unfortunate cases of human children who have been maltreated, and we've done some of that research ourselves, you see that the actual size of the frontal cortex is diminished in those children. So being subjected to either emotional abuse or physical abuse actually leads to contraction, to shrinkage of these areas. We've also done studies of children who have been raised in orphanages in Eastern Europe, primarily Romania, where they have suffered emotional deprivation, and they've been then adopted into middle-class families in America. And the age at which we test them is at about 12 years of age, roughly. And they've been in the orphanage for different lengths of time, but at least for 6 months and up to about 5 years. but then they've had at least 5 years living in a middle-class family in America, and what we see is that their brains are still very different when we test them.
남산 리바이 제도 말다.
So that suggests that the restoration and revival doesn't take place
That
easily.
is, it does not take easily. That is absolutely true. It is very true, and one of the questions is how best to help those children to restore or to take over, have other parts of the brain take over functions that are impaired by the parts of the brain that are contracted. It's a very difficult problem.
내가 뒤도 만들 주어지 transfer한다 할까?
Yes.
middle class 로서만
네.
밀리언은 adult 중에면 되게.
So it's just an aside question, nothing to do with your presentation. His Holiness just, thought this question. Since you talked about middle-class families adopting, what about millionaires? They don't adopt?
Very rare. Seems very rare.
Is it rare that they adopt?
I'm not sure. Does anyone know the answer to that question?
I think suppose the millionaire, so much money, they can adopt. 그래서
The book adopt 제발이야. 닝지 the cage.
재산가. So I'm just curious. You see, you specifically mentioned middle class.
Yeah. And it's in our data that we've looked at when we have advertised in newspapers for families.
Yes, I just wanted to tease you.
Even scientists, to millionaire, very polite. So not carry test experiment.
His Holiness is suggesting that the scientists are being more deferential towards the rich so that they don't subject them to experiments.
Yeah. We test all comers. But, when we advertise, Your Holiness, in newspapers, these families really want to participate in research because they have a lot of difficulty with their children. And they're searching for answers. So they have a motivation to participate. And we have many more people volunteering, many more families than we can. But the families that respond to our advertisements are all middle-class families. They're not from the very, very wealthy. So let me move on a little bit now. I'll skip this slide in the interest of time and just show that I want to introduce the topic of neuroplasticity just to say that neuroplasticity is not necessarily good or bad. It is neutral, and it depends upon what input we have. If we fill our minds with wholesome thoughts and warm-hearted emotions, then we can harness neuroplasticity for the good. But if we're exposed to adversity and to a lot of negative influences, that can have a deleterious, a negative effect on the brain.
같은 네거티브래. 양고 플라스틱 폐야 요말배.
간다다 플라스티시스 labjukol 코로나는 전에 루마데레스.
띵무데
그래서 콜레바년지 되게 시게 benza. 다 대단한 볼이야. 겐디 녜베차 테베나 대쪽 녜베 초파 교원도 그러봤어. 겐디
들어봐. 안들 레베 제 폐야 줘봐. 폐야디 직진난도 콩주식 전부 아제식 전부 제비나 레베 폐거래.
나는 폐야라면도 다 두번도 해서 그런 plasticity. So can you explain how the negative exposure has implications for plasticity?
아주 잡아도 인지 되게 따서 가서 로 상부시 제비나 레베 제 유원도 되게 소. 레베 폐야서 레베.
폐야스네. 다
플라스티시티는 잘 쓰거든요.
년제도 봤어 그래. 년제도 봐. 교원도 녀봅시나.
자상그 네 요르야지 롱냠부식 싶게 있는 요르고래.
So His Holiness was saying that he heard that as a result of exposure to a positive mental environment, such as the experience of compassion and love and so on, in fact give rise to a strengthening of neural connections as well as maybe even birth of new neurons. So does the same effect can be seen in the negative exposure as well?
It can, although the effect tends to be in opposite directions. So this is one example.
어 디셔도 그래. 레벨 저러다 제저 레벨 제기 모두에 가서디 emotion positive 다 positive 는도. 그 레벨 regime 페벨 regime 레벨 제기 응진 두고 그래.
레벨 제고 토네 랑. So does
So
that mean
that los sangusti izane level 제기 도다르티 그 상부 저러서 시. right. 다 안다 롱네버스티 izane 롱네버스도 로 현시티 izane 자자가 레벨 핀두랑 그 돈에 로 상부 있는 게 뭐인지 다시 해줘야 돼.
So given that there seems to be a suggestion that at the brain level itself, at the neural level, there seems to be preference towards more constructive mental, like emotions and so on, and there seems to be
Although I would say the preference is early in life.
So His Holiness's question is, does that mean that even by looking at the brain,
Well, you mentioned some positive sort of because of the emotional feeling, some positive impact.
Yes. Yes.
So constant fear, anger, this negative emotion, negative or I
Damaging
don't
effect,
know, some kind of emotion are more negative.
destructive, damaging.
So that means the physical sort of particle, the small particle itself, you see, have some kind of ability, distinction. What kind of emotion? Can
Can you say that?
That
On the part of the neurons.
Yes, there are neurons which will, individual neurons. Christoph the other day mentioned neurons that respond to very familiar people. There are neurons in the brain that will fire only in response to positive input, and other neurons that respond to negative. So there are neurons that make that distinction clearly, and there are circuits in the brain that are primarily dedicated to positive emotions and others more concerned with negative emotions. So there clearly are those distinctions that are made in the brain, absolutely.
그래서 그런 거라다 양다보다 양도 세면도 딱고 tumbe쳐다 미tumbe쳐 시야스도가.
long. Then jipam sheba mato. Long. Yes.
더 초용 동. 홀리스틱 쉐비는.
So, and this is an example, Your Holiness, from research of Bruce McEwen. You met Bruce McEwen at Rockefeller University. He's a very, very eminent neuroscientist. And he has done some of the most important basic research. These are individual cells. And on the left, we have cells from a control animal and then an animal that has been under chronic stress. And what you can see is that the extent of these processes from the cell, these are the dendrites, they actually are fewer in number when the animal is highly stressed. And these are cells from the prefrontal cortex as well as the hippocampus. Those are areas of the brain where stress leads to a contraction, a diminish size, if you will. And the interesting thing is if you look on the right-hand side, those are cells taken from the amygdala, as well as another part of the prefrontal cortex, which we'll not talk about now, but let's focus on the amygdala. And you see the top is from a control and the bottom is from an animal that has been stressed. And what you can see there is that the branching is greater. And so the amygdala is an area of the brain that is particularly responsive to threat and to negative.
So how do you define control in this particular context?
Control?
Yeah.
Control.
Yeah, control
It's in this particular context, it's an animal that has been just raised in a normal way and is getting fed properly, getting nourished, healthy.
And the stressed one is induced.
The stress is induced.
Right.
Yeah, and the way the stress is induced is by putting a predator near the animal to make the animal anxious.
그래서 amygdala이 더 숙철도록
Amygdala 나로야.
more active.
So it seems that in
Alert, something. Alert.
Exactly. Vigilant.
Vigilant.
Vigilance.
Yeah. So this, I've described some about the circuits important for emotion. I'd like to now move on and talk a little bit about networks that are important, networks in the brain that are important for attention. And just as for emotion, we think of different aspects of emotion. We've talked about wholesome and unwholesome emotions. We've also talked about the capacity to regulate emotions. When scientists begin to work in an area, they begin to make distinctions. It's kind of like the Abhidharma with lists of mental factors. And so here it's much cruder, but some distinctions. And with attention in the same way, attention is not just one thing, but there are different attributes of attention. And what I'll show is that scientists have studied some of those attributes, and some of them can be distinguished in terms of which parts of the brain are most important for those attributes. So there are three types of attention that are denoted in this diagram. One is called alerting, a second is called orienting, and a third is called executive control, and I'll explain each of these. Alerting is if all of a sudden now there was a big loud noise, which like happened to us yesterday. Some people would turn their attention to the noise. That is what we mean by alerting. So something happens in the environment and our attention is pulled to that. We think of that as attention which is stimulus driven, and we say stimulus driven because the external stimulus pulls our attention toward it. So that's one kind of attention. The second kind of attention is orienting. If I were to tell you...
Orientation, 쳐.
Can you explain?
Orienting.
Yeah, orienting.
Yeah. So for orienting, if I were to tell you that in just a second or two, I'm going to flash a stimulus just to the right of your eyes, and you know exactly where it's going to be occurring, and don't move your eyes, keep your eyes focused ahead, but very, very soon I'm going to show a stimulus there. The orienting is the capacity to direct your attention, not mentally, not with the eyes, but just mentally to that location. And you can do that with any sense. So we can be sitting here now and directing our attention to our right foot and the sensations there. That would be an example of orienting. Executive control is where we resist distraction and direct our mind to focus on one thing and inhibit the distracting influences that come from somewhere else. So, for example, if we were standing in a room with many, many people and engaged in an interaction, and if I heard my name being called, I would have a natural tendency to orient or to show an alerting response to my name being called. But if I focus my attention and remain in that conversation, that is executive control, being able to inhibit the distracting influence of the other sounds and keep the mind focused on what it is directed toward.
아주 템버터 그러죠.
표정 아주 로다
심주나지는 템버터.
가 띵지 골미고 디간다 내배 차로 충충증 아주 여러 와
라레.
두번 내가 잡아
미벌이야. 미벌이 현도 마양은 네버 제베 젤레데.
어떻게
템베감도 그러면 좀 못받네 제베나.
왜? 띵지도 가래.
예를 제베데 띵지도 셈 지지도 네베 차트체. 더셈 미벌라 마양버. 미벌이 현도 마양버. 징년디.
Now, one of the fascinating things is that these are different parts of the brain that are.
His Holiness is Richie trying to correlate that with the Abhidhamma taxonomy and trying to understand in functional terms.
전배 벽에 내버 채우러 그 내배 차로 돼. 전부 자이나.
Yes. The nebe. Yes.
그 일이 실로 디간 속
Nare. The Tana the executive control the neighbor chebet. Chigendre.
내버 지지대.
Executive control the chigendre. Then a magic that to the get here then that's
근데 오리엔트지 고야지고 리디니로
오리엔트로
안 미고 디간
총이
되고.
오리엔트 로파 총년데 이 떼년데.
One of the things that
Because in Abhidhamma taxonomy we speak of mental factors in specific functional terms. So there is a mental factor which is often translated as attention, manaskara, and this is the factor that selects what you're going to focus on. Then there is a mental factor that is the ability to stay single-pointed. And then there is a mental factor whose function is to, in some sense, like executive control, so that you don't get distracted by some other stimulus. You maintain that focus.
두번 매번 잡아도 띵지 싫어. 띵지 요물해.
띵지 요래 나.
군주.
유행.
유행이래.
나로 유행. 두번 매번 잡아도 띵지
저도
싫어.
sababdu시다.
두번 매번 잡아도 띵지 싫어. nga보 유일.
지라보는 중이죠. 이브로. Yes.
So one of the things that's interesting from a neuroscientific perspective is that there are parts of the brain that are involved in these different attention functions that overlap with emotion. And that is not surprising because when we ask ourselves what information in our environment tends to capture our attention, it tends to be emotional information. For example, we show alerting responses to stimuli in our environment which are emotional. We don't show those responses to stimuli that are very neutral. And so it's not surprising that there is some overlap in the brain regions which are important for emotion and attention.
So
these are the two sides of the brain, yeah?
No,
Same
sorry.
brain.
This is the outer surface
yes.
of the brain, and the
diagram
on the right,
yes,
yeah,
is
is
inside.
center, yes, it's cut in the middle.
Right.
Yeah.
lo yulo yuwa cheba di simchung sambe chile isla gorwa. Tatanda kudu di alerting se lo yulo yuwa cheba dre. Manchu di jik samlang de bang piki dat ding slap na ham sam sem pa chon gorwa.
Now, in the interest of time, I'll just give one example, and then this afternoon we'll have more time. So I'll give one example of how we can study the impact of contemplative training on networks important for attention, and this afternoon I'll talk more about emotion. This is the quote that Arthur put up the first day from William James about how the education of attention is so important. And William James said, his last line here, it's easier to define this ideal than to give practical directions for bringing it about. I think if William James had contact with the Buddhist tradition, he would have seen immediately that the methods that are so rich in your tradition, Your Holiness, represent strategies for educating attention. So this is a little hard to see, but children who have attention deficit disorder, which about 15% of children in the West between the ages of 7 years old and 16 years old are said to be diagnosed with attention deficit hyperactivity disorder. And many of those children are being given drugs to somehow help with this. We think that there may be other strategies for doing it. One of the things that kids with this disorder show is that they're very variable in how they pay attention. Sometimes they can pay attention, other times they're distracted. And so they're just very variable. And what this simply shows, it's a technical way of demonstrating that their attention is very, very variable. So we asked the question whether 3 months of vipassana practice can reduce this variability and thereby improve attention. And so this was a study where we tested participants who were going. This was a Theravadan retreat center that you've been to, Your Holiness, the Insight Meditation Center in Barre, Massachusetts. We tested practitioners who were practicing in a 3-month retreat. And we tested them before and after the 3-month retreat. And if you look to the right, the practitioners are labeled in these columns on the right. The practitioners are on the left side of that figure that's circled. And the white bars are how they responded before the retreat. And the gray bars are how they responded after the retreat. And what's being displayed is their variability in attention. So improved performance here would be reduced variability, decreased variability.
Thank you.
The novices who just practice for 1 week, they're the same when they start out with as the practitioners, and they show no change after 3 months, no change whatsoever. Then we also measured the brain. And I should point out that this is work that was directed by my colleague Antoine Lutz in our laboratory, and you've met Antoine on several occasions. He was actually one of Francisco Varela's last students, and after Francisco passed, he came to our lab. And what we show here is there's a specific measure of brain activity that's very, very interesting, and the best way for me to describe this measure is by using a metaphor. The measure is called phase locking, and it's phase locking between the external stimulus and what's going on in the brain. What the participants are doing is they're asked to pay attention to sounds, which are presented in headphones. And we have sounds that are going along, and every now and then there are tones. Every now and then there's a tone of a different pitch. So it may be like this: boop, 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 beep. And the practitioners have to notice when the beep occurs, and it's going into each of the 2 ears, and they're instructed to press a button when the beep occurs only if it's in one ear and not the other. And when the beeps are going very, very quickly, it's actually a very demanding task. And what we can use this task to track what's going on in the brain. Now, this phase locking can be described in this way. If you have a lake which is very, very still, and you toss a stone into the lake, if you're on the other side of the lake, you would be able to see the ripples in this very still lake. If the lake is turbulent, if there's a lot of waves, if you toss the stone, you wouldn't be able to see because...
Yes.
So this is the same in the brain.
Beautiful metaphor.
Pardon?
Beautiful metaphor.
Oh, thank you. I learned my metaphors from Mathieu La, who is the master of metaphor. I take no credit. What we see in the brain is the same thing. And what we see in the brain is that over the course of 3 months, the practitioners show a stiller mind. And so they are able to show a synchrony between the occurrence of the beep and the measured response, particularly in the frontal part of the brain. And so this is the primary change that we're able to track. So there is much more to say. I've only gotten through about 25%, but we'll have much more time in the afternoon. I want to be sure to leave the same amount of time for my very dear colleague, Tanya.
Thank you very much, Richie. That's great. And we will have time this afternoon to pick up on these themes. So why don't we swap chairs?
Thank you.
Right. Can you bye, Tanya?
Thank you, Richie.
So Richie oriented us towards emotion, attention, and the effects of training, for example, on attention. We were able to see the power and possibilities
Richie?
of the training of the human mind by means of these exercises. You have to pull up your finder.
I don't have the mouse.
Hmm?
Where is the mouse?
Go to...
Do you find the mouse? But where's the mouse? Where's the mouse? The mouse disappeared. Because that's the presentation. Computer frozen. Computer frozen.
Computer. Net.
I don't know where the...
Mouse
Also-
disappeared.
Also me level got is shared as a computer level tosta nyopsha.
So maybe the computer is rebelling because we've been extolling the virtues of human brain.
So the computer brain nyore so.
So it's like the
Can you-
computer is bored,
Huh? Did it? Oh, can you?
It disappeared onto a second and invisible screen. It turned out that it was hiding in
Some
another
here.
part of the universe. So now we're going to be hearing from our distinguished colleague Tanya Singer, who comes to us from Germany and the Max Planck Institute in Leipzig.
So what I wanted to do, His Holiness, is a great honor to talk again. I will present some things you heard in Delhi, but with
Yes.
more time, and we can go more in discussion, I hope. So what I want to do is to complement the view of Richie, but coming to the question of whether we can train compassion and empathy. So I think one monastic scholar asked in the first day whether we can also find brain correlates to something precious like compassion. And I will... And I hope I will show you that we can find correlates. The question about how they relate is another question, the hard question of consciousness, as you said. And we will have another meeting tomorrow about the question how experience and neural correlates hang together. What I also want to do is to tell you a story about how the working together of monastic monks, in that case my favorite guinea pig, Mathieu Ricard, helped us to understand our models better. So how we kind of combined first-person perspective and experience with our methods and how we developed a new way of thinking through the cooperation. So let me introduce first a model we developed as the basis for a one-year longitudinal mental training study. And we will start in 2 months, so I cannot give you any data from 1 year, but I will show you data of 1 week and several weeks. So as Richie said, when we start doing mental training or plasticity research, we first have to define which cognitive processes we want to focus on. What do we want to cultivate and what do we want to train? And so cognitive psychology came up with a lot of different distinctions. So for example, here we will train the first 3 months attentional abilities, like Richie was just telling, like just coming back to the present moment, bringing the mind back from the past or future to the moment here. And we also train interoceptive awareness. And interoceptive awareness is getting aware of signals from the body. Hot, cold, heartbeat, so on. And I'm not talking today about that, but each of these processes have particular circuitry in the brain. Each process can be distinguished in the underlying circuitry which subserve them in the brain. Now, we have 2 other modules of 3 months everyday training, which we call affective and perspective, which is more cognitive in nature. So in the affective, we train something like loving kindness, increasing thankfulness, feeling of warmth and concern and compassion. But also we learn what Richie was saying, what do we do if we have anger and fear? You cannot go directly into compassion if you're full of stress and anger. So how do you solve this problem? And then in contrast to that, the perspective block is perhaps what in Buddhism is called view or wisdom. It's a bit like the 2 wings of compassion, I think. So it is more related to an understanding, a cognitive understanding, and what we call, for example, metacognition. So cognition would be memory, attention. Metacognition is to become aware of what your mind is doing. It's like 1 level above. And you also need this capacity to become aware of what you have for conception of self. Get aware of construction of self and how self operates. Okay, so now I want to show you why these distinctions. So that's a model now just to show how we think about studying plasticity. So what we usually do when we start such a training study is to measure, for example, also genetic information of the subjects and information about their upbringing, mother, the parents, the children, because we want to see how differences in the genetic makeup, but also difference in how people have been raised, predict how they will learn, and whether different types of people will learn different methods more easy or more difficult. And I can come to that later. And then we assume that mental training changes the brain. This is the concept of brain plasticity. And that these changes help predict changes in experience, subjective experience. So we measure subjective experience, but also on another level, health. So we measure stress hormones, heart rate, immune system, and so on. And then the last level is behavior. Do people act differently? And so, as Richie showed you yesterday, we have a lot of different tasks which are, designed to measure attention or prosocial behavior and so on. So that's the basic underlying model of this research. Okay, now, why do we separate these two? Why do we make this distinction? Partly because a field which is called social neuroscience and which wants to understand how do we understand other people? How do I know what you feel or what you think if I'm not in you? How do the brain solve this problem? And over many years, there has been more and more insight that there are different routes to the understanding of other people. So either I can feel what you feel, and this is what we would call an emotional or affective route. And this is, for example, empathy and compassion belong to this affective route. They are phenomena which reside here. And then there is another way to understand other people through knowledge-based inference. So, for example, this would be, because I know that Buddhists have a view that consciousness exists also if the brain dies, you have different assumptions than Western scientists when they are materialists, and they think consciousness collapses when the brain dies. And this kind of inference is... That's an inference I do not because I can feel something, but because I know about Buddhist philosophy, and it's a cognitive inference. And you call that cognitive perspective taking. To some extent, I can go into your mind because I know about the world and about your thoughts and beliefs. But I don't feel, I'm not in an emotional resonance. And the empathy route, the definition of empathy, is that I can directly go into emotional affective resonance if you feel, for example, pain. I feel pain, like my own pain. So this is an affective resonance which is directly and feels like something, it's not cognitive. And then I will show you why it is very...
compassion is empathy.
So just confirming what you are suggesting, that because when you feel very strong compassion for someone, you actually have a much stronger empathetic connection with that person.
Ah, okay. So we can discuss that, because we understood a lot about empathy, but not a lot about the construct of compassion. And we only through time and studying these phenomena.
나를 다는데
엠퍼티스는 소화 매르들 여러분.
조여부터 니 조여부터 안다체 다는 쿠란지 더간다 엠퍼티다 컴패션데 소외 규람 그 돈이 없지. 또 다는 미기 시행기 남데 삼당당지데 남주 배주제 줘야 돼야 랑가카가레스. 다는 모란 슈단 제는 체리부도 담보 동심 때마도 닝지를 안고 리스타 규요 말레스. 정말 제바치도 정말 숙제 엠퍼티.
그 누수 가서.
엠퍼티세들. 엠퍼티세.
Yeah. So in a way, the difference between empathy and compassion, and I will tell you how we got also to understand why it's very important to make a difference between these concepts, is that compassion is not necessarily only to feel the same thing than you feel. So if you are in pain, I'm in pain. If you enjoy, I'm in joy. This is empathy. We share the same state. But compassion is more, you can be in pain, but I can feel concern and a motivation to want to relieve your suffering without feeling the pain. This is possible. To have compassion, which is a warm feeling, is also an affective, motivational state, but doesn't have to share the pain. And when you look into the brain, and many studies have shown, if that empathy and compassion rely on different networks in the brain than this kind of more cognitive way of understanding the world. And the green pathways in the brain are showing the cognitive perspective taking, the understanding network. And they develop later in children. Whereas the pathways which have been referred to as emotion circuitry or limbic circuitry, which are orange, like the insula, they develop early. Children with 1.5 years have already empathy, very early, before their brain matures to be able to make cognitive inference. So we are connected in a way of affect earlier than we are connected in an understanding way to the other in childhood. Okay, so let me now focus on the research between empathy and compassion. Why do we do the difference? Why, is it important? So, when neuroscientists started to want to investigate such phenomena like empathy, they had the hypothesis that perhaps, how can I feel when you have pain, even though I don't feel it in my body? I don't have pain, so how do I know how you feel? So the hypothesis was that observing your pain activates neural network in my brain, which usually process my own pain if I really get pain. And through this activation of networks, which are first-person pain network, I can now understand, this is how it feels. I feel it in my body and in my brain, basically. My brain codes for it. And we have a lot of evidence, which is called the shared network empathy hypothesis, that observing other people's emotions activates the same neuronal circuitry which process the very same emotion in myself. So now the problem with that is, if you suffer, then I suffer too. Is that helpful? Is that helpful for me being a good person, pro-social, helping the world? So even though in the West people always say it's good to have a lot of empathy and it's something we have to train, we were not so sure. And when we met Mathieu Ricard the first time, we asked him to come into our lab. And you see here, these are monks in the lab, and on the right side, Mathieu Ricard, which coming out of a brain scanner after 1 hour of torture from us. Because we had access to a modern technology which gives you, it's called real-time fMRI. So while he is in the scanner, we can see and we ask him to go into different states of consciousness. Compassion, sometimes imagine afflictive emotion. He was not good in imagining afflictive emotion, better in compassion. But we can see the brain activity while he is in the scanner doing all these different states. So we asked him to go in different states. And first, we asked him, can you go into different compassion-related states? So what he did is different ways, what he calls, but he will tell you more what he did from the inside. It's non-referential compassion or loving kindness. And what was stunning is that I thought that he is now empathizing with the suffering of someone. But the brain signal which came out was totally different. It didn't look like the hundreds of studies we had made with untrained brain. So when he came out, I asked him, what are you doing? Are you not suffering, not feeling the pain? Because the network is so different. You are activating a network we know is involved in positive emotion, warmth, and affiliation. And so Mathieu explained from his first-person perspective what he was feeling, and that it was a very strong motivation and warmth and concern, but not necessarily pain. So we forced him to do empathy for pain. We said, you go back, and now please just go in empathy and suffering with the other, and don't go in compassion. Stop and just imagine suffering on your body. And here we saw the signal. We saw the pain-related network lighting up now. So at least we said, okay, Mathieu has a normal brain. When he imagines suffering and really goes in empathy, he can show that. And this helped us developing a model where we differentiated between the capacity of empathy and compassion. And so our model would state that we all have empathy. We are born with the capacity to resonate with the suffering of others. However, if it's too strong, it can turn into personal egocentric distress. You know, it can lead to very negative emotion and stress and to overwhelm. So this is the pathway down there. And why is this important? Because in helping profession, a lot of people make suicide. Doctors, nurses, a lot of people which have to deal with everyday suffering end their lives because they cannot cope. They don't know how to cope. And the suggestion is that if you know how to turn empathy, resonance, into compassion, then you are safe. Because you know how to develop positive emotions of concern. It's about the other, not about me. And you develop pro-social motivation, a strong motivation to help. So, you know, it's nice to have one brain like Mathieu, but science doesn't believe in one brain. So to test this model, we started to do different training study. And this is just a 1 week. It's very short, but it's a beginning. And we trained one control group in memory. It's a mental training technique to improve memory. And the other group in loving kindness and compassion. So probably I don't have to explain people here what loving kindness is. But given we had a secular training, we said to the students, it were students, university students, which had never done any practice, we said, start with imagining, for example, the picture of your mother, or a dear friend, or a loved one, or your children. And just try to improve this. And after and then we scanned their brain before and after, and they watched videos of news, small news pieces from BBC about suffering in the world. There is enough suffering in the world. So we had hundreds of news segments of dying people, starving people, women crying because they lost their children in accidents and so on. And we scanned the brain of the participants when they were watching this very, very negative, strong material. And we asked them how much negative emotion you felt, how much stress, negative emotion, and how much positive emotion. And non-trained people, at the beginning, all reported very negative emotions when they saw this video. And it was going along with activation in a network which was known to process negative affect, stress, alarm network. It's like very big. So now we...
when you use the word negative and positive, what the basis?
The demarcation, what's the definition? How
the
do you
definition
define?
of...
And also is when you mentioned wholesome, right? Wholesome
Yeah.
thoughts.
So I think there is a difference between Buddhist tradition and Western science, that we don't define emotions in terms of their function, whether they are adaptive, wholesome, or destructive, but according to the qualia.
Negative check.
Yes, this is secular.
So that's fine. Tanya.
How wholesome was the Kasoda talks based on secular.
Tanya, am I right in informing His Holiness the way in which modern psychological sciences distinguish between the two is when the actual emotion arises, how do you feel?
Yes.
If you feel good,
Exactly.
then it's positive. If you feel
Negative
and bad
Yes.
and unhappy, it's more on that spectrum are negative. So it's really kind of a phenomenologically defined.
Yes.
Is that, am I right?
It's
And His Holiness says,
aversion. It's aversion, the feeling of aversion and liking.
Just to point out, I think this is going to be one of the most fruitful areas of dialogue between Western psychology and neuroscience and Buddhism, because I think that the wholesome-unwholesome distinction has not been tested in a serious way in Western science.
Yeah.
And I think that that is something that we can test. And it would lead to a very different organization of emotion, and I think it has many important implications.
And another...
Still, I believe this is Kasoda, based on
It's a secular context.
So when we use the word Buddhism, then it's secular marta.
Right, so when you say Buddhism, then it has non-secular aspects.
But, yeah.
So that's why you see, I think at the beginning in Shemasanganda, Buddhist science,
Buddhist science lang.
she needs to shit, secular.
So because if we bring that aspect from the classical Buddhist sources that really pertain to exploration and understanding of the actual nature of reality, then it will fit nicely within this secular framework. So earlier His Holiness was saying that this distinguishing between positive and negative based on affect is actually suits nicely within the secular context.
Yes.
Simply, it's some kind of feel happy,
Right.
feel comfortable. That's
Positive.
since we want that, we appreciate that, so we call positive.
Positive.
Something, although I think some people, I think when develop, you say anger, perhaps they get an anger and with some harsh word, I think the person may get some satisfaction. But this has a short term, right?
Right.
Long term, the constant anger very bad for their health. So therefore, consider negative.
Yeah. But I think
Not
one
talking about next life or not talking about nirvana or these things. So,
one of the crucial emotions, though, will be sadness, because sadness can sometimes play I think, beneficial role, and it may, in the moment, not be associated with happiness, but it may have some, I think, beneficial quality. But we can talk about this later. But anger is clear. Anger is clear.
sadness is the cancer study. I think according to Buddhism, Four Noble Truths, the first Noble Truth, you see, actually, you see because of some connection with sadness, right? But because there is alternative, third Noble Truth, and there is a way to achieve that fourth Noble Truth.
Yes.
Therefore, thinking reminds sadness is something fruitful. Otherwise, no use.
Exactly.
Okay.
And perhaps you could even now, in this model, say,
I think the context because secular 시샤비나 sadness use 그게
그지 샤고마로
영가
샤고마로 근데 수수 년이도 시월이야 지금 sadness 맞중 체마통이 되기디 양 미규마 지마로 and sadness 용배 갱기한테 동네 제한테 뒤주고 secular Quran 나로래
sadness kanina. I think recognition of suffering. Here, I think, as you mentioned, is make distinction, empathy, and because of compassion. Right? Sadness, so realize this is this sort of suffering. This is the cause of suffering. More deeper sort of thinking about that may not bring sadness. I think that more holistic. Now, for example, the Four Noble Truths. Once you see you have clear picture about third Noble Truth and the proper way achieve that Four Noble Truth. Is thinking more because of the suffering. You get more because of the will. Enthusiasm. And because of the deep down, there's some kind of tremendous courage, tremendous sort of
courage.
And I think some kind of very, very, very positive sort of mental sort of attitude, full of courage. So that I don't think sadness.
no sadness. Do you need to
Sadness
feel
doesn't
suffering?
because of demoralize. That's sadness. Realize the suffering, and even you feel, but full of sort of determination, full of willpower. I don't think there is sadness. Oh, French expert. What do you say? What do you say? Do you agree? Oh, it does. Yes, sir.
And do you think that you need empathy for suffering first before developing compassion? Do you think it's...
닝시동에 망주를 사지 여러 왔다. 되는 말 왔다고.
시엔 동안 나와 통도 니지 게임도 걸은 시엔 동안들이 동심 예, 그렇죠. 깨고 말해.
동수 고로.
동심 깨 먹어. 니지 깨 두르.
동수 냠지 세대 들어. 이네 표기 동에 소아디 영원에서 깨게 하자 싶을 것 같아.
So
It's
it's a slightly complicated issue because in the Western conception of empathy, there seems to be a suggestion for the need for resonance. So so it suggests that in order to have empathy, the person who is feeling compassion also needs to feel the other's pain.
Yes.
But perhaps I think someone physical pain, passing through physical painful experience. You see, there's no possible way, impossible. You see, to get your own physical pain. No.
You can.
But mentally, yes, very painful sort of feeling.
So mentally you feel the pain of the other, but not physical.
저상가 pain 사이드 cancer should develop too.
So it's still
It's very.
it's a tricky.
It's
I mean,
very-
it's a difficult question.
It's very interesting. Perhaps I may add some neuroscience on pain. The pain, when we have a pain network,
I think usually is my sort of explanation. The sense of concern of others' well-being. There are two types. One, biological factor. That's biased, too much mixed with attachment. That sometimes you see may get sometimes because of the
Distress.
distress or demoralize these things, because the attachment based on ignorance. Now, biological factors sort of that's because of the sense of concern or affection. Take as a seed, then utilize human intelligence. Then, with help of human intelligence, you see that feeling of sort of sense of concern of others' well-being, then reach another level through training, not a biological factor. Now that unbiased, without attachment. So any sort of emotion based on attachment or based on ignorance, always a limitation, always a limit. The other one, so some strong feeling or emotion which is based on reason, logic, or intelligence. Now, on the other hand, the mind, no shape. So, the limit may also.
So one could almost say there is no limit to how far it can go.
with compassion.
So there's unbiased. So maybe I think the second level of sort of sense of concern of others' well-being is, I think, because of much related with conviction, determination.
So there's a courage as well. In that there is a courage and it's voluntarily adopted.
That kind of affection only human being can develop. Animal, no, because no intelligence.
No,
So that under the empathy, the compassion, that they can use shaman or some chance. The biological canon do the
So much of the current scientific description of empathy versus compassion is really very rooted in the biological processes. So His Holiness is wondering, in teasing out the relationship between the two, we need to bring in the compassion arisen as a result of trained process. So in which case the relationship may be a different one.
That training, certainly we can develop, because of that through training, that kind of that level of compassion. Or non-believer to non-believer.
Even among non-believers. You don't need religion for
yes,
that. Yeah.
Yes. And I think His Holiness pointed out something very important, that I think as long as these training studies just 1 week, it's very short, we tap in systems which are very primitive. I mean, for example, the system which we see activated after 1 week of loving kindness training is a system which is known to be, associated to affiliation. For example, to rewards. If you show mothers the picture of their newborn child, you would activate a similar system. It comes with feelings of warmth and love and positive feeling, and our subjects also reported that. Even if that's not the compassion you talk about, the higher level compassion, because it's kinship, it's rooted in a system which is which came about biologically because of mother-child bonding. This is a very old system, and animals have that too. I think that at the beginning you use the system to develop the feeling of compassion. And now an interesting question is, what will we see when we do a year or 2 years of compassion training? Will the subject show very different networks? And I think yes, but we don't have the answer yet. This is the first step of developing. But I think it is very important that we can show that even after a week, subjects can change their brain. And they are not children, they are adults. And in Western society, there is a lot of plasticity research in the motor domain, in memory, but not so much in the heart domain. So showing that after a week you can change network, which are motivational affective network, is already a big step. And another, I think, important take-home message is that now these people were given something new, because before training, the suffering just flooded their brain and they had very strong stress reactions. Now, after 1 week of loving kindness training, they started engaging a new system, which is a rather positive system of feeling of warmth, strength. We asked them afterward, how did you had a different experience? And they reported it was fantastic, because now we were not so helpless with this whole suffering, but we could put something against it, which is warmth and concerns, and so we felt less stressed. So the idea is that if we can develop compassion, this is what we would call also perhaps for medical profession a better coping strategy than either being too empathic, overwhelmed with negative emotion, burning out and suicide, or they get cynical. They just disconnect, don't feel anything anymore, but then it comes with a withdrawal and not with help, not with a contact. And so I think these data show that you can give something else, which is compassion, and that has a biological basis at the beginning. And then I think to get universal compassion, that's a big step. You need probably the frontal lobes, because you have to override in-group, out-group distinction. So what we can show in other experiments is that people have empathy for people they like, and they think it's in-group, it's my group,
Attachment.
But in the moment you only say the person now sitting to your right getting pain is an out-group member. He is from another football club. Then empathy is gone. We don't measure anything. And this is a very biological response, mine, in-group and out-group. And to overcome that, you need training. You need to develop and to develop. And so we need longer studies than just a week.
Empathy, I think actually is very much based on self-centered attitude.
Exactly. Yes.
Compassion is level, the compassionate animal
So,
according to your sort of definition, empathy and compassion.
Yes. Empathy is self-centered.
It seems to see empathy cannot extend towards your enemy, troublemaker.
Exactly.
The compassion can go?
Yes, can.
Oh,
exactly. Yes. So if
now very clear. 사당의 최면에다.
최면에.
최면에 디 장도로. 아주 미직벌이 동해면도 미직벌사도 신부이나.
말하다 디 empathy 차.
그 달리 다 미토로.
또 달미 베네 신 동안 다때 동안 나와 메시지로 시켜고.
들어.
티케볼라 다 empathy 로지면은 달라 칸데스 게토.
엠버티면에. 또 엠버티는 그런 거 사시면 되네.
타직도 self-centered Islam나.
Yeah.
So I was just taking an issue with you, Tanya. I'm just disputing the characterization of empathy as being self-centered.
It can lead to.
Because, for example, even through training, an ordinary person, now we're not talking about in the Buddhist context,
Yes.
we're talking about a secular
Yeah,
context. As a result of training and compassion, an individual may be able to develop compassion to someone that the person, sees as a rivalry,
Yes.
a kind of a rival or an enemy.
Yes.
But in order to generate compassion, the person has to feel connected.
Yes.
Empathy needs to be there.
So this is what we have in this model. Empathy needs to be there. This is our presumption. A little bit of empathy needs to be there, always. It's neutral. It's basically I can feel the pain, and so I know I have
So
to
I
do
think,
something.
Tanya, can you describe in plain English what exactly do you mean by empathy?
Empathy is just the ability to share feelings with others.
Risha?
Very simple.
No, did you
Yeah.
self-centered
And now, empathic distress is when you get so much, you share so much, that then you get preoccupied with feeling so bad.
네 섭섭서 디소다. 네년리스. 스즈는 섭섭을레소. 디동이 나와들 미술로 기는자네. 타르도나 네년리스.
So, for example, like in natural setting, we tend to feel strong empathy towards our kin.
Yes.
And
Yes.
the reason why His Holiness was characterizing this as a self-referential, at least, if not self-centered, is because the underlying reason has to do with me.
Yeah.
Actually, you
It's my
mentioned
kin. Yes.
the person is from your body. Then, as soon as it knows that person belongs to another sort of group, then no
Yes,
longer is
then
that
it's
feeling.
over. Yes.
So mine,
It's mine.
the feeling of mine,
Yes.
No.
But the capacity.
So that also I usually make distinction. The biased compassion very much oriented about others' attitude. The unbiased compassion, not regardless their attitude. So your enemy, attitude very negative, but still they sentient being or human being. So on that level, you see extend
Yes.
sense of concern of their well-being. So much dealt with, and then also, I don't know. Okay.
So I think this is what you are talking about. This is the model I showed at the beginning. Cognitive capacity need to join the affective capacity. And only when they come together, you can go to a wider compassion. And the training study here we show are first steps in developing the concern and warmth and motivation. But they are not developing yet the higher capacities of equanimity and non-biased compassion. But I think what is important is that even though empathy might be, like you said, a neutral capacity we have to resonate with others, to feel what others have, it can turn, it doesn't have to, but it can turn into a very self-centered, distressing, and non-adaptive state, and lead to a lot of problems in nursing homes or teachers. And so it's important to know the difference between the wholesome state of concern and compassion and the non-wholesome state of distress. It's a danger.
Empathy the empathy channel 남주가 만단 그래.
So there's two routes. The other route, when empathy turns into personal distress,
Yes.
I mean, is it a function of empathy, or is it a sort of a function of a lack of some other faculty, like
Very good question.
cognitive, like understanding?
Yes, I think it's a mix. It's a very good
저도
question.
이제 이러다 그 규진 현실의 단어를 되게 냥가도 엠버트를 하는 소리.
So if that is the case, then why would you blame empathy for it?
No, you are absolutely right. So there is studies showing that even children, very young children, differ already. For example, the mother starts bleeding, and some children respond with distress and facial, and they go back, and other people other children go to the mother and help and have no facial expression of stress. And so it's probably also individual difference, which are very early on in childhood, in the person itself, which determine how you react, whether you have a tendency to go from empathy in distress, or you have a tendency to go from empathy.
닝도.
And probably it also has to do with confidence, and courage has to do.
Yeah, and then I think you can train to learn to go the route up and not down by, for example, learning to regulate your emotion, learn to view the world different, not me, but like what is the other, to get the focus to the other, and to have a clear self-other distinction. So another thing we can see is that empathy gets into personal distress if it gets emotion contagion, you call that. It's a very unconscious melting for me and you. I don't know anymore that I'm a different person than you. It's very often with mothers and children. They get very stressed when the children get stressed. But that doesn't help the child, because then the child gets even more sad and distressed when the mother gets distressed instead of caring and soothing. And there is very interesting research in developmental psychology about mothers being different too. This depends on their attachment history with their own mothers, whether mothers can just be compassionate and caring towards children in distress, and other mothers cannot. Other mothers tend to go into distress, which leads to a big difficulty for the child. Because then the child, instead of getting calmed down, get even more stressed.
가서 아마 가져오자.
그랬다. 근데 아메리카 간도 릭 개발도 가서 수수 치라고. 아메리카 부구 마이키 중배가 감산 장부체.
들어.
아메리카 이제 부구 마이키 부체 깨접지 제가 수수배 샘투. 대체인도는 부구도
So it will be, I think, a future research determining who are the people who tend to go into personal distress, and what can you do to train people to go into the other arm, the other route. The consequences for health services can be very big. And in Western societies, medical doctors do not get training. They don't get training in this affective mental capacity. They are put into the doctors, into the hospitals, and they have to deal with a lot of suffering, but they don't get any mental training. They're left alone with their constitution, and that's a problem. So Jim Doty will tell us more about that probably.
James, I think if you want to make a comment, you need to make it with the microphone.
This one's not working.
Somebody check the microphones, please. Make sure they're working.
There's one here, I think one.
Yes, just as a physician with a great interest in this topic, you're absolutely correct. I mean, unfortunately, physicians are not given enough training to get insight into their own feelings and how to process them, and to show you even the mindset that still exists on some level, although I think it's dramatically changing. I had a conversation with a dean of a major medical school regarding the fact that we should teach the students, the medical students, compassion training to make them more resilient to deal with these issues you're talking about. And his statement was to me, quote, the students' curriculum is already too full to teach compassion. Now, can you even imagine that the core basis of us being physicians is our ability to be compassionate, and in Western medicine, it is disregarded. That being said, we're seeing a renaissance, if you will, based on this work, and the insights that have been garnered from neuroscience, which is completely changing this view. So we're now seeing at a number of leading institutions interest in these contemplative practices in regard to training healthcare workers, resilience to decrease burnout,
Yes.
and we're already seeing a significant impact. Unfortunately, medicine can be very recalcitrant when they're showing new ways. It's like elders who are set in their ways, they do not wish to change. And it will take some time, but I'm really confident that we're beginning this process.
근데 지단 맹게 대전 나로야 교단이야
마가시게 알레
디시우죠 그래서
다시 저좀 서로다.
양 가르다 다 고전 소리지.
안도 로좀 줘야죠.
나
참조 로좀 줘야 돼. Yes.
No, I think we've come to a very significant, in some sense, challenge, because what we're pointing to is something of, I think, general applicability. The middle way between coldness and cynicism, or abstract distancing from patients and those in suffering, in order to maintain our own equilibrium and dispassionate concern. You know, it can become very cold. On the other hand, if one becomes so involved, then the other extreme leads to burnout, self-destruction, and so forth. And so we tend to move between these two extremes. It's almost like a madhyamaka position. It must be a middle way where there is empathic concern. One does connect to the feelings of the others. Those are shared, but then they're held in a way which is, you pointed to the head, they are held in a way which allows for, you might say, intelligent response as a physician, as a caring and concerning person, as a mother or father or companion in life through friendship, so that the heart and the mind are together here also. I think of the arts, it's another element, you know, the beauties of nature, the work with the artistic element also requires that quality of the feeling life be held in a certain balance, so that we can write those beautiful words of poetry, or give the painter, as painters, representing things with beauty. I wonder if are there practices for holding that middle way within the Buddhist tradition? Are there ways of schooling so that one really does possess the resilience, the quality of alertness and clarity without grasping?
잡식이 어려서 뒤도 다 그러셔. 지용기다 그나 가수래. 샤라 기도난데지 싫어진게 기도를 써야죠. 가지인다. 지단 미지기 남주 매정이지기 익스트림 강도 되게지글 싫어기니 삼자고. 믿을 싫어기니도.
Generally, in many instances such as this, the role of our understanding and insight really plays a very important one. Something that other people may find very difficult to hold, but with a little different perspective, and bringing your insight allows you a much better way of handling it. So it's really the role of insight and understanding.
No, not only is the inner world sort of concern, but
in many
everywhere.
areas.
The meaningful dialogue means, you see, use intelligence, interest there, interest in our interest, and make balance, not by emotion, but by intelligence. So everywhere.
Could I just comment on the statement you made, which is profound in many ways, but the other interesting aspect of that is, if you look at artists and some of the greatest works that artists have conceived, they are actually have grown out of immense pain.
Yes, right.
And so
그
there's no
아티스트,
que-
아티스트 리무진이
아티스트, I see.
So while, of course, our desire is to relieve suffering, many great things and insights can be gained as well from suffering.
Yeah, by great effort and great
그래서 아티스트의
willingness to
쇼대.
suffer.
간다 지다 리무케바다 제 개보만 보지 고란서 계획이 있는 나로래야 동해 슈신 보지
제유도
좀 물어봤지 장아주 지단 동해세 장아주 미유레데 이내 한 동해래 동해게 깽게야 세제만 보시에 좀 그랬어.
Your Holiness, I think Richie has a theme he would like to introduce.
Well, it's a theme that I'd like to pick up on from some of your comments, Your Holiness. You have talked about to realize unbiased compassion requires training. And my very limited understanding of the Buddhist tradition, at least in some components of the Buddhist tradition, would hold that when we have a human birth, we come into the world with a luminous mind that has the quality of compassion, and that the practice of contemplation is one of familiarizing ourselves with what is already there. It's not actually training something that's not there, but rather recognizing a quality that is already inherent.
That's right.
And so one of the struggles that I've had as a scientist is trying...
qualities and disha고요. seed이다.
So it's more in the form of a seed rather than full-blown qualities.
Okay. But one of the fascinating things that's been happening now in the scientific arena is in some of the studies which Your Holiness has heard a little bit about that are now being done in very, very young infants. These are infants that...
Oh, yes.
Infants.
5 and 6 months of age. They seem to exhibit unbiased compassion in certain respects. So they
Yes, I think.
Several different experiments now have shown this.
Some extent, right? Some
To
extent.
some extent.
Yes.
Also agrees.
To some extent.
True. Very true.
And so one conjecture, one hypothesis is that very, very early in life, we have those qualities, and then as we develop, we encounter suffering and our minds get tainted or colored. And we then, as adults, the training that we need to do is to rediscover these qualities which may have been present as seeds, as you say, earlier in life. So is that an account which makes sense with the Buddhist tradition?
I think not only Buddhist tradition, but all, I think, major religious tradition, which stress importance of practice of love and compassion. Means all of it.
말했던 쿠란 슈에 내가 들으셨던데 남배 차셰 가시에 싶은단 제베나 닝지다 잠바다 되기디 맞수 상물을 랑체수 예베 캐주레스
또 들어 시드 보면 샤나와.
또 시드 캐주레면도 랑체수 예베 캐주레스 디엔자네 잠바 곰니지 곰두가 체도니는 니지다 잠배 연된 장기요 말은 나를 여버디 세버 치료를 시제 데이터스 투스 답에 창조 고모시단 투스면도
야 빼야. 근데 쉐어 누가 가서 춘주간에 여러. 때는 들럭복도.
So it's really more in the form of a potential. For example, the potential for knowledge exists in, if
awareness.
and basic capacity for awareness exists. But in terms of education and to knowledge, we really have to cultivate it and improve. So similarly, he would see these qualities more in the form of potential.
Well, one of the things that the way I often describe this is we know that language is something which is a unique human characteristic, but there have been some case studies of feral children, children who are very unfortunate, have unfortunate development and are in the wild and are not raised by families and are alone in the wild. And they do not develop the capacity for language. It's not that they don't develop the capacity for language, they don't show language. They don't speak. And in the same way, could it be that compassion is something which is a potential that we all come into the world with, but we require a community around us which exhibits that compassion in order for that seed to be nurtured? And it's really fundamentally the same as language. If you're not raised in a linguistic community, you won't develop language. And if you're not raised by individuals who are caring, the seed won't be nurtured and you will not exhibit compassion.
저선 가서지.
일부러 배준 잡에나 가르치고 나서 배는 게 잡에도 그때 시에 그 누버티 보고 정말 여러 봤어. 이네들 단대 로규 전에 갑가실이 보는데 신망 그 레제. 제마서는 그 시에 맞고 연구 여러 봤어. 이 난신기 먼저 정말 충분히 닝지다 잡았는데 게 누버 가서 정말 랑치서요 나야. 치 고유고 돈에 겐체제 딘누버디야 즉 자기는 좀 맞대배나 남지질이야 닝지도 잠바 make it today. Those is a Of course, environment plays a very important role.
Then I think basically the biologically social animals and not social animal also is differences. So then we human beings social animal. Now here again, then I think as we already discussed, the intelligence is the key factor to promote these some good values. So in order to the dealing with intelligence, language is very sort of the important matter.
Mathieu Ricard also has a comment he would like to add. If
Yes.
we just turn our attention to him.
So regarding what Tanya and Arthur and James said, many nurses, they are taught they should keep that balance, not to be too close emotionally, and not also to be too distant. If they are too distant, they don't care. If they are too close, then as they suffer with the person day after day after day, then it's too much. They're overwhelmed, they burn out. So that is true if the only thing they have is this empathy, only empathy. So the point is not to get rid of empathy, of course. We want still to continue to be aware of the other's feeling, but not only empathy. If we only have empathy, then we will have to be careful all the time, not too much, not too little. So the role of loving kindness and warm heart and compassion is to provide a bigger space, like a buffer, so that we have much more resources to deal with the suffering of others without burning out. So maybe the small example, the electric pump to pump water. If they turn without water, then if they turn too fast, they become very hot and they burn. So we need water continuously to cool them down. So that's maybe the bigger role of loving kindness, compassion, human warmth. It prevents the negative effect of just empathy left on its own. So that can turn into overwhelming distress. And then we either leave the profession or we become cold. We don't want to feel. So that's why adding the space of compassion makes such a big difference.
Tanya, did you want to
And I have
join your voice? Your Holiness?
I have another question to His Holiness, because you said it's mainly the intellect which will allow to develop compassion. And when we look into the brain in these very first steps of loving kindness, we see very strong activation of motivational system, of affiliative caring system, which are the basis, for example, for mother-child caring, but also later for relationships and so on. So we would say you also need a motivation and emotion. So for example, love is conceptualized in the West as an emotion. We conceptualize love as an emotion. So would you not say we need both a motivation and emotion and intellect to develop full compassion?
Motivation system di no job cerebudon ta na shukche emotion ko khonda de go yodi bala ta sherab ko to na ning ji ga ke ba nyam bol ya ya ning ji jobal ju ge che tu kulong ki ya cha she de nyam bo jang ko na dos
ji yong ji xia yin de ba ta ning ji de zhen dun bie ji zhuo是对面就地上面了，写了个长些糊涂。现他同样跟两个要的。
So generally speaking, if you look at many of the qualities.
但是公路的那些国家的，也写了个长些糊。
So for example, if you look at many of the qualities such as compassion, loving kindness, and so on, which are in the psychological Western psychological conception more in the affect domain. In the Buddhist conceptualization, we would refer to them as belonging to the mental processes that are more in the style of aspiration and yearning, so
grasping.
And there is a recognition that in order for these kind of processes to really be more efficiently directed, it needs to be, in some sense, steered and complemented by the insight and the wisdom factor. And even with respect to motivation, in order to ensure that the motivation is directed to the right one, again you need the role of insight and understanding. So it's in some sense, intertwined.
Yes.
That is something.
So that's how he would see it. Because if we just stay purely in this domain of what the Buddhist psychology would refer to as this kind of class of aspiring, yearning processes, then there is a danger of falling into extreme.
I think another word we can say physical action, verbal action, mental action. Whether the action become constructive or destructive,
So yesterday we spoke about intrinsic absence of intrinsic existence.
So things are relative. So now intelligence have the ability to judge. Under these circumstances, you should do this. Under these circumstances, you should do this. Like that. So I think that all the credit goes to wisdom, intelligence. I feel. So we have I think fortunately, perhaps that God creates, we have some special sort of ability of intelligence. Now that really sort of individual case, you see, real teacher, you should do this, you should not do this, for your own long-term interest. So education is so important. Certain sort of the emotions, it looks very positive. So with blind faith, it may create problem. So make balance, judge, holistic. Emotion, no holistic. So only intelligence, look holistic. Do you agree? Yes. So these experts, brain specialists.
It's a high aspiration.
And Your Holiness, the area of the brain that many of us have been talking a lot about, the prefrontal cortex, is an area where thinking and emotion come together. It's such an important area where they converge. And so we can, when we use our thought to direct our emotions, that's something that seems to involve the prefrontal cortex. And there, because of its connections, these areas come together. We call it a convergence zone.
그것은 직도 되어서
Does it
손도
develop
져.
over time?
손도 져.
That particular area?
직도 기분 말아.
Implications
손도
for
져.
education, for example.
근데 코란스 단지나 레제세링돈 대변나 네 뒤응게는 prefrontal cortex리아 emotion다 남주 대화중심 부여배 인자스 아니 되게 자주 개심부시 통도로서 더 건지 송도 되어서 찍부 잡으세요.
되죠. 인터넷에서 스트리밍도 한다. 아주 뭔가시 뭐시 해야 되는데 인터넷 시험을 한다.
So we speak a lot about the brain regions that are involved in emotions, but what about brain regions that are involved in intelligence and
The ability of investigate which part of brain.
Depends which kind of intelligence. So many scientists today would argue that there are multiple kinds of intelligence. There's the intelligence that is measured by the IQ test. There's musical intelligence. There's the intelligence that we think of as emotional intelligence, which our friend Dan Goleman has studied extensively. So it depends on which kind of intelligence. And I think that one of the important issues here is recognizing that just as there are many different facets of emotion, many different facets of cognition, there are many different kinds of intelligence which would be represented in different brain networks. One of the things we do see is that on very gross, coarse dimensions of intelligence, there does seem to be some scaling of relative brain size with intelligence. So if you look at brain size corrected for body size, so larger creatures have bigger brains in part because they have bigger bodies, but if you correct for the size of the body, generally speaking, there is a relation between the relative size of the brain and the coarse definition of intelligence. So there is some relation with overall brain size, but that's a very crude way of thinking about intelligence. When us neuroscientists think about intelligence, we want to know what specific kind of intelligence we're talking about.
당연 디어치로 인텔리전스한테 공간 시험부터 대등해지 인텔리전스도 와. 난 들어가도 로봇들이 시작와. 그래서 제도 거들이 지금 들어와시도 와.
So,
즉 심주시하세요. 심주시고 어디는 심주시에서 유디 이루 양양을 타는데 심주시하지 말아. 지금 뭐라면
so the 인상 코란전 남주세 때 대생카가 치료를 남주스라도 도도질 문제 제도요 말했어.
그래서 아는 게서 다른 데들이 센서를 간 누구도 와. 센서를 때문에 변하는 거 남에게 무슨 뜻이 저주도 해야 돼. 누구 좀 마도 시 또르도 이루 걸어가는 로디 걸어.
So some of the kind of varieties of intelligence that you talked about, so quite a lot of them are very intimately connected with sensory experience. But the intelligence that His Holiness is talking about is
music or sports.
sports. Yeah.
The mental is sort of judgmental, right?
Judgmental.
Or analyze. But you see, mainly based on sensory.
Yeah.
Very sensory experience.
이루 양양을 통해서
So His Holiness is talking about the sheer ability of the mind
다 그것은
to
시대에
apply itself.
또또또미 여시다
To apply itself. So we have been talking about conceptual versus non-conceptual.
Yeah,
so this is in the domain of thought.
So I have put this slide back because the network which allow you to reason and reflect about the minds of others is nearly the same network which allows you to reason about your own mind. And we tend to say that this is a network which gets activated whenever thoughts get stimulus independent. So it's like, even if it's dark, no sensory input coming
right.
in, I'm thinking with myself. There is a midline network between medial prefrontal and parietal lobe, which is sometimes also called default network. Default network is because you don't give any task to the person in the scanner, and you will see this network lighting up. Why? Because the person is thinking. Even if the eyes are closed and no task, the person is thinking and reflecting upon themselves.
공회시의 유인이 중대 왜 참바이 물어봐. 든지. 딱 네가 그냥 들어가셔야겠다.
But these are, even though
Yeah,
the
you-
sensory perceptions may not be active, but it is kind of tapping into the memory of the experience of the
Of course,
senses.
yes. So you need to retrieve from memory, from somewhere, information what you can combine. Yes.
But I think His Holiness is referring to, if I'm correct in understanding him, referring more to the reasoning process. You know, the processes that are associated with the reasoning.
That's
Yeah, I
also.
mean,
Moral
there-
But
reasoning,
the one that you're
logical
talking about is the
reasoning.
default. That's a sort of a
Yeah,
habitual kind
It's
of,
like
you know,
reflecting
is
about
that- yeah.
episodic things.
Th-
and
There,
so on.
there is, I mean, there has been some studies done of that sort. In fact, there have been studies of Einstein's brain. I actually once held a piece of Einstein's brain. It now is in several different universities. And there have been studies of one specific part, mostly, which is a part in the parietal lobe, which is toward the back of the brain, where different sensory systems come together. Vision, audition, and touch all come together there. And Einstein has descriptions of thinking in images. There is some suggestion that there is increased connectivity in that area of his brain, which may have been associated with his unusual skill at engaging in that kind of reasoning. But these, at this point, are really, I think, very gross conjectures. We still don't know very much about that.
근데 아인슈타인 두제리안 실로운 거 붙이 가는 야도 심주심 제셔서다.
But as Einstein was a genius that focused, you know, extensively on understanding the nature
Again,
of
up to now,
reality.
the because of scientific sort of research work, something is based on our sensorial seeing.
He was more a theoretician. It was based more on he was a theoretician, which means it was based on reasoning more than on any kind of experiment or observation. He thought about what might be the case. And then interestingly, he described how he came to it was often by feeling as if he were moving, and then images, and only at the very end words. So it was a kind of non-conceptual thinking to begin with, and then became more and more conceptual. He often used music. When he invented his general theory of relativity, he came down in the mornings, his wife could see he was distracted. He said, I have perhaps the best thing in my life I'm on the verge of, and he sat and played the piano. And then he wrote notes and played some more, and wrote some more notes and played some more. After half an hour, he went up, and in the next 3 weeks, he stayed in his room the entire time in order to develop the logical formulation and mathematics of that theory. But it was as if he was bringing it into words.
Maybe that music provided the kind of calmness that he needed to
kind of
think
meditative
deeply.
meditative quality that allowed him the peace to bring his thoughts to clarity, full clarity.
I think one thing, though, that is really important to emphasize, and we've said it with other constructs like attention and emotion and Tanya's work on empathy and compassion, is with intelligence, there's not going to be any single brain area that is going to be important for intelligence. It's going to require a dynamic and complex interaction among many different brain circuits, and what patterns constitute intelligence in certain contexts is something that is still requires much investigation. But I want to just make one other point, and that is scientists can learn a lot from dead brains. And I think that we need to actually have a brain bank for lamas. Seriously.
그래서
네,
체류.
체류부 저기 미시교 레바네 안내주 망부시부 또 토에
어, 네.
고갑이 어레스
네.
띵자 아니 근데 그좀봐 남nem바다
Don't look at me.
라마 주제바 샤니 저 샤니 여러분 싱글페니 들려요봐
어.
저기 에 레바냐세 뱅치 코스레스
가지고 있어.
bank
어.
now
That has played the brain banks, that is, banks of dead brains, have played a critical role in understanding schizophrenia and autism, major disorders, and I think that we can glean some very important information from accomplished practitioners.
랩에 참으들이 패지 가서 그게 number 10 가서나 패지 매버샤는게 배랑 아주 잘 남샤 먹지 가서 그게 더 쏴가르잖아요. 디 가르도.
But many of the, whether you want to call it traces of the experiences and so on, may actually not be there once the brain is dead. Because, for example, in the Vajrayana text, the description of the various experiences related to the prana, the wind and the energy channel movements, once the channels are
Some very subtle, very, very
damaged
thin.
and destroyed, they are not thought to be there.
So therefore, much better like as the living guinea pig.
It's better to use living guinea pigs.
It's nice when we can talk to them.
That's subjective.
Then you can bring in the subjective dimension as well.
Yes.
Now time for lunch.
Now time for
Time
lunch.
for
Thank you, Your
lunch.
Holiness.
Thank you
It's
for
been a wonderful morning. Thank you. Good morning, Your Holiness. Today it's my privilege and task to be the moderator, so you don't have to listen to me present. We have two wonderful presenters today that will be speaking to you about changes in the brain and the neurosciences. Yesterday we spoke much more about the intricacies of the natural world, the world of physics, and especially contrasting the world of classical physics with that of modern physics. And we learned something about the ways in which the interconnectedness, the holism of nature is now more and more a part of our worldview. Even our technologies now can make use of this interconnected, holistic aspect of the subtle dimensions of the physical world. We also spoke about how Madhyamaka philosophy chooses a middle path between a kind of naive realism and a mind-only school of projection. We saw how that also seemed to relate to the foundations of quantum mechanics and relativity theory, and how these scientific theories seemed in harmony with that philosophical position. All of this was done again at the hand of the natural world, the world of reality outside of us. And we can think of that exploration, that investigation of the natural world either by the methods of Buddhist philosophical thought or the world of physics as part of the exploration, coming to clarity and wisdom concerning the natural world itself. And I know Your Holiness also has such a relationship to the environment that this study of nature is also something which is not merely intellectual, but allows us to establish a heart connection also to this world of nature, to its beauty, its grandeur, and it is important for us to care for that world as well. I think of this as one path, a path that takes us from ourselves and into the world of nature, its beauties, its mysteries, its subtlety. But there's another path, which is the path that takes us to the mind, a different threshold, a different crossing into the mysteries of consciousness. And we have today two remarkable scientists, both of whom are known to you. Richard Davidson, of course, at the University of Wisconsin, who is the director of the Weissman Laboratory for Brain Imaging and Behavior, and also for the Center for Investigating Healthy Minds at the University of Wisconsin. He's known to you as a neuroscientist and cognitive affective neuroscientist of the highest rank and order, and of course one of the early members of the Mind and Life family, and has been with us for a long, long time. We also have Tanya Singer, who sits to my right, who you also know, who helped to co-found or organize the Altruism and Compassion in Economic Systems conference in 2010 in Zurich, but is also a neuroscientist of an extraordinary caliber in Germany, now directing a Max Planck Institute for Human Cognitive and Brain Sciences. She brings an enormous capacity and expertise here with her from this, and that's with great joy and gratitude that we are welcoming her into this circle once again to present to you from her standpoint. And so with these two capable individuals, we now begin our path into the mind through the lens of science. So Richie, I'll turn it over to you.
Thank you so much, Arthur, and thank you so much, Your Holiness, and thank you to all at the Drepung Monastery for making this a very, very special and momentous occasion for us. For those who are visiting, it's been really something very different than any other Mind and Life meeting, and I think we all feel it in our hearts and understand at least a little bit, I think, how important this meeting is for Your Holiness and for the monastic community. And I think, speaking on behalf of all of us, I think we all feel a real gratitude to play a small part in the curriculum change that this event is really celebrating. Today, Your Holiness, I will begin to talk about neuroscience and also contemplative practice. On the very first day of the meeting, I said a few words and talked a little bit about the complexity of the brain and how it's probably the most complex piece of matter in the universe. After sitting through yesterday, I'm deeply humbled by my physics colleagues, and I think that neuroscience now is a much easier task than after knowing what my physics colleagues have to struggle with. So we'll see at the end of today what the collective judgment is. So, Your Holiness, today I will first talk about two major systems in the mind, if you will, or two major constructs. One is emotion, and the other is attention. And I talk about these because from the perspective of Western science, there seems to be consensus that contemplative practice affects these processes. That is, it affects our emotions, it affects our afflictive emotions, it affects our positive emotions, and it also affects our attention. And so from a Western scientific perspective, it makes sense to us to begin this project by focusing on these constructs which we think are relevant to the impact of mind training. And so I'll begin by asking, what are the key neural circuits that underlie emotion and attention? And then we will consider the idea that these circuits are plastic, meaning that they can be transformed by experience, and therefore they seem to be relevant for the opportunity to be transformed by contemplative practice. And then finally, I'll talk about the impact of different kinds of contemplative training on both emotion and attention, and I'll give one or two examples. And so that's the plan for this talk. I want to begin with an important figure in psychology and neuroscience from the West that has already been mentioned at this meeting, and this is William James. And in addition to his insights about attention, which we've heard a little bit about, and to several other experiments like that, suggest that at least to some extent, William James was correct. Where he was not correct is in thinking that all of it is due to the feedback. So it goes in both directions.
Now safe though. 찾아내보세요. 그렇게 인 것은
말에 찬이가 레베나는 마 베스로도 마 따다 미네야 따다 촌니가게 돈에 연구요레스 까브리 멤버체 단데 윌리엄 제임스 송베나 당봉엘레 왕부 티체 안 왕부 레벨 레베 마 따다샤 마도 어디 나 지나게
제일에서
단디 코란스는 다 촌니가 투서
So another important figure in the history of research on emotion is this scientist named James Pepys, it's pronounced, Pepys. And he was the first to actually describe a circuit in the brain that is important for emotion. Not just one location, but the interaction among a group of structures in the brain. He was the first to describe that. And his description is in this figure, and it includes a number of different parts of the brain, such as the hippocampus, which I'll talk a little bit more about in a few minutes, another part of the brain called the cingulate. But all of the key parts of his circuit are enclosed in the dotted square. And notice that the neocortex, the highest part of the brain, is outside of that area. It's not part of the circuit that Pepys described was important for emotion. Now, this is very important in the history of neuroscientific research on emotion because it was suggesting that emotion is processed in parts of the brain that do not involve the cortex. And this was the classical view of emotion for many, many years. And then one of the things that changed that view, one of the most important things, were studies that were conducted primarily from individuals from World War II who suffered damage to their brain in the war. And one of the things that was found is that patients who had damage to the frontal lobe of the brain exhibited abnormalities in their emotion. That is, they showed certain kinds of emotional disturbances. And those were some of the first insights that suggested to scientists that in addition to the parts of the brain that Pepys and others have described that lie below the cortex, that the cortex itself, at least certain parts of the cortex, particularly the frontal cortex, may play some role in emotion. And so what might that role be? And that has been the focus of a lot of basic research that we have conducted in our lab, but also many other scientists. And the modern understanding suggests that the capacity to regulate our emotions is importantly associated with the frontal cortex. And one of the things that may be different in humans than it is in any other species is our capacity to regulate our emotions. No other species can voluntarily regulate their emotions in the same way that humans can regulate their emotions. And we think that that probably has a lot to do with the deep influence.
No, that retakanda jignana the longonju berwa. Jignana the kita longonju berwa. Longonjurwa. Longonjurwa in dugal that.
So one occasion, some scientists used to told, fear develop, then the muscle goes leg, the blood
goes
more.
into them.
So obviously, anger comes, then blood circulation go hand, ready to boxing. So that means, you see, the physical sort of change, this blood sort of, also the rushing, that's naturally related to the heart and some other sort of body element. But trigger of that is here, feeling, fear.
The fear.
So I thought, if fear come first, then physical reaction come later. So you just opposite.
That's right. So this is William James's view. So which is right? So how can we test this scientifically? So I will provide one example of how this can be very rigorously tested to provide an actual empirical answer to that question, which comes first? Is there a way to tell? So in the West, Your Holiness, it's a little bit strange, but there are people who go to their doctors to receive injections in their face to make their face look younger. They receive injections of a molecule that is called Botox, in short. And what Botox does is it paralyzes the muscle for some period of time, and it eliminates the wrinkles. And some people voluntarily go to their physician and get an injection of Botox to make themselves look younger. So we actually did an experiment.
So Solon said that, he was saying that if you go too extreme one day, you might not even be able to close your eyes.
That's true.
Can blink, sorry, too.
Yeah, to blink.
It's true. It's true. So we did an experiment. This is published in the scientific literature, where we decided we can take advantage if people are voluntarily doing this anyway.
That's right.
What we did is we tested people before and then after they received a Botox injection to the muscle, one of the key muscles in making certain kinds of facial expressions, the corrugator muscle, which contracts during sadness, for example, very important. And we then were able to test the same person before and then after we eliminate the skeletal muscle contribution that goes back up to the brain. And so this is an important way to test William James's theory, because we're not changing the brain directly. All that's changing is the signals that would arise from the muscles that then go back to the brain. So we can, at least for the skeletal muscles in some key regions, we can eliminate that feedback that goes back to the brain, and we can ask the question, does that change a person's emotional response? And the answer is, it does. It has some effect. And so that experiment, as well as which we will return later this morning, William James also had some brilliant ideas about the nature of emotion. And I'd like to share William James's understanding concerning the nature of emotion, and that is depicted in this diagram to the right. And I'll walk through this diagram. If you look at the right-hand side of the diagram, it says sensory receptor. Those are the sense organs, the eyes, the ears. And William James's notion is that sensory information comes into the brain through the sense organs, through the eyes, through the ears, and so forth. And it goes up to the cortex through some relays, which we'll talk a little bit about later, but eventually it reaches the cortex, the highest level of the brain. And then from the cortex, if you look at the arrow that is denoted number 2, there is a line going from the cortex down to the viscera, which are our visceral organs like the heart, the lungs, and so forth. And so there are projections, there are connections. This is William James' view, but this part of it is clearly confirmed by modern science. We know that there are pathways from the cortex that go to the heart, that go to the lung, that go to the different visceral organs. That is known, and that's not controversial. So,
His Holiness is asking, are you suggesting that these visceral organs play a role in perceptual processes?
They play a role. They play a role in emotional processes. So the idea is that the brain is perceiving the senses, and then once the senses are processed, the information goes from the cortex down to the visceral organs and also to the skeletal muscles, to the muscles in our face, the muscles in our body. And then just to continue, the arrows that are denoted number 3 project back up to the brain from the visceral organs, from the heart and the lung, as well as from the skeletal muscles. They project back up to the brain. So for William James, what he argues about emotion is that when, for example, if we see a tiger in front of us, the sensory information goes up to the cortex. The cortex sends signals down to the heart, down to the lungs, down to the muscles, and we experience our heart beating more quickly, we flee, and then he says we experience fear only after those changes occur in our body. And so for William James, the changes first occur in the body, and then the signals from the body go back up to the brain and inform the brain about the state of the body. And then once the brain detects that the body is agitated, then the experience of fear arises. So in a very famous passage in William James's book, The Principles of Psychology, he says, we see the bear, we run, and then we are afraid. So this is a view which has had a very